Hi folks, we're going to take a look at number 6 from part 3 of the multiple choice course review. So they're asking us which expression is equivalent to cos x. Okay, so in some ways we're going to try to eliminate the ones that won't work. And I look at these three, A, B, and D, and I notice they all have something in common. Sort of this portion here and these two look a lot like the cosine double angle formula. So let me just write down the cosine double angle formula on the side, just so that I can make reference to it. So cosine double angle formula says that cos of 2 times some angle is equal to 2 times cos squared of that angle minus 1, or here the other version, if I take a look at D, is 1 minus 2 sine squared of that angle. Okay, and this is what I'm going to use to help me try to simplify some of these. So let's take a look at A. So if I take a look at A, I look at that numerator, and it has exactly this format here. So if I compare it to the cosine double angle formula, this whole thing inside the bracket is going to act like my A. So I can simplify the numerator as cosine of 2 times whatever this expression is in the bracket, which is 1/2 x. And so when I simplify that, I end up with cos of x. Okay, except I have this numerator, this denominator portion, which clearly is not equal to 1. I would need this denominator to be equal to 1 in order for the whole thing to be equal to cos x, and there's no reason to believe that that's true. So I think A is out of the picture. Okay, so let's look at B here. And again, I have something that looks very similar, except in this case, my A is going to be, if I look on this side of the equation, my A is going to be 2x. So this can be simplified as cos of 2 times whatever this value is, 2x. So that's equal to cos of 4x, which is clearly not equal to cos of x. So B is eliminated. And in fact, D is almost identical. Okay. Because it just follows this pattern here. So the 2x is like my A. So again, this is equal to cos of 2 times 2x, which is cos 4x, which is not equal to cos x. So D is gone. So as a multiple choice question, by process of elimination, C must be the answer. Okay. But let's actually show why C is the answer. So, in a university course, sometimes this is how you're going to have to determine your answers. If you can eliminate all the other possibilities, the one that's left must be true. Okay, but let's actually show that this works. Now here, this kind of might look a little like the cosine double angle formula in some ways, but I think the best thing to do is, since we don't have any direct identities involving secant, let's take this secant and turn them into cosines. Okay, so if I take a look at C, I have 2 minus, and I'll just turn this into 1 over cos squared of 1/2 x. And I'll do the same thing in the denominator, turn this into 1 over cos squared of 1/2 x. Okay, and let's work completely in terms of cosine. Okay. So as we often do, we want to turn this into a single fraction. So I'll use a common denominator, which is going to be cos squared 1/2 x. So I'm going to have to multiply the 2 times cos squared 1/2 x. Okay, minus 1. I already have that denominator in the second one. All over cos squared 1/2 x. Oops. There we go. And here, dividing by a fraction is the same as multiplying by its reciprocal. So I'm just going to turn this division into a multiplication. The reciprocal of 1 over cos squared 1/2 x, of course, is just cos squared 1/2 x. And that works out really nicely because that reduces now with the one I have in the denominator. But look at what I have in the numerator here. I have something that looks a lot like the cosine double angle formula. So this is my A value. And if I apply this formula in that direction, this whole thing in the numerator is just equal to cosine of 2 times 1/2 x, which of course is just equal to cos of x. And so we've proven that C is indeed the answer. Okay. Although from a multiple choice perspective, we saw that we could have just eliminated the other three, meant that would have to be the answer. But since you're unlikely to get unlikely to get a question that's multiple choice. You should know how to actually solve it. Okay, so just to recap, step one was to notice the relationship between these three and the cosine double angle formula. And the other thing was to realize that almost every time you're working with secant, cosecant, cotangent, and tangent, it's often a good idea to turn that into sine and cosine, especially if what you're trying to prove it's equal to contains a sine or a cosine. Okay, that's it for this one.